Today's video is sponsored by Bluetele, the ultimate in IT asset management. For more details, visit them today at blueteleapp.com. In today's episode, I'm going to teach you IPv6, a core essential skill for networking. Can I do it in 10 minutes? Let's find out. As Obi-Wan Kenobi once said, well, hello there. Welcome to the episode. On today's show, I'm going to talk about IPv6. It's a core networking skill that, to be quite frank, if you want a job in IT, you simply have to know this. So it's in Microsoft, it's in Cisco, it's in IC Squared, it's in CompTIA. It's just one of those skills that you need to know. Now, IPv4, of course, the Internet Protocol, it launched in the 1960s and the 1970s. Who knew? It had billions of addresses, but who knew that the Internet would grow to what it is today? So we had this 32-bit binary address. We've had it for years, and we still use it in many cases. But of course, mobile devices, smartwatches, IoT devices, they all need more. And of course, we've run out of IP addresses. So what's the solution? The solution is IPv6. Now, if you haven't subscribed to my channel before, I would love to have you on board. So bump that subscribe button, ring that bell, and come and join us, and hit the like button at the same time. It does make a difference. Now, coming this, in fact, a week today, next week, I'm actually running Dive Deeper Tech Days. And this is a whole day of live seminars. I'm delivering it over Zoom. You can join in, you can ask questions. It's going to be lots of collaboration. You'll get copies of all the presentations and all of that. 99 quid. You can't go wrong with it. Seriously, sign up below. It would be great to see you. Okay, now, likewise, if you've got questions about this or any of my other topics, as always, get those down below. And I will do my very best for you. I'm also on Patreon as well, so your support is really appreciated. And of course, remember, you do get access to full courses there as well. Okay, I think without any further ado though, let's jump in and let's talk about IPv6. 10 minutes. Let's see. So, IPv6 in 10 minutes. Really, Andy? You can teach me that? Well, let's find out. So, to understand IPv6, you need to understand IPv4. So how does IPv4 work? Well, it starts with an IP address, like this. So this is essentially a 32-bit binary address, and it's segmented into 4 bits. We call these pieces of 8, if you like pirates. So essentially, it's an octet. And an octet, essentially, if I look at, let's say, 192.168.32.152, this is pretty much what it's going to look like. So to understand that, of course, you need to understand binary. So we take 192 and we break it down into its binary components, and it looks a bit like this. Again, if you don't know that, it works like this. So starting at the left, 128, 64, 32, 16, 8. Do you see a pattern emerging here? So 164, 128, 256, 5. That's how computers work, my friend. So you just take any number between 1 and 255, because 255 is the broadcast address and 0 is the network address. So in this case, I've taken 192. 128 plus 64 is 192, and that's it. That's binary. That's how it works. So we take that and we move forward then. So if IPv4 uses octets, I've already mentioned that IPv4 addressing is fairly exhausted because there's basically not enough addresses in the world. So what the internet have done is we now have IPv6 addressing, and IPv6 uses a unique type of address. It's called a hextet. And this hextet is not 32 bits, but 128 bits, so much larger address space. So with that in mind, again, how does it work? Well, we take the first hexadecimal, and just an example of a number here, you can see that I've got just one part of this number is 0. So look at the binary option here, and you'll notice that 8 plus 4 plus 2 plus 1, what's that? That's 15, right? So 0 is 0, so the answer is 0. So what if it was 1 then at the end? How would that look? Again, it's still binary. Right, so basically what you're saying is you've got 4 pieces of 4 there, you see. And then we can basically say, okay, what's next? Well, let's take the address. Well, there's a B or a D in the address here. So there's a D. What does that mean? Well, because this is hexadecimal, it's a 16 base number. So again, 16 is you can't use that number because it's the network number. So it has to be between 1 and 15. So when it works like this, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then A is 10, B is 11, 12 is C, D is 13, E is 14, and F is 15. And then it starts all over again. You don't need to be an expert. That's pretty much all you need to know. So you can see we now have this massive address space. And in fact, there are enough addresses for 16 million devices per person on planet Earth. So I don't think we're going to be running out of any IP addresses soon. So when we compare an IP address like this, you can see that D, I said that D, of course, was 13. So 8 and 4 is 12, plus 1 is 13 in binary, and it's represented by a D in hexadecimal. Simple, huh? So looking at this IP address, you can see that this is how it would equate to a binary address underneath. 128 bits. Whew, that's a big address. And looking at this address, I'm thinking, wow, would I really need to type all of that out? Golly, you'd be there forever, wouldn't you? Well, actually, there are a few little tricks that you can use to shorten it. And one of those tricks, well, first of all, I mentioned at the beginning, it's a bit like a phone number. So think about a phone number. A phone number has a country code, an area code, a city code. You might even have your telephone exchange, and then you'll have your host. So the network address uniquely identifies what network you're on, and the host is the host address. So basically what we have now is this huge long address, 128-bit hexadecimal address. Looks pretty scary. But there's an awful lot of zeros here. Can we do something about that? Actually, there is. Where you get 2 sets of 4 zeros like this, you can basically squash them down by using 2 colons. So that tells the system that there are 8 zeros here. But what about the other zeros on the right-hand side, or the other 0 there on the left-hand side? Well, the good thing is, the interesting rule is you can only use this double colon rule once. But what you can do is you can basically squash those 4 zeros down into a single 0 and remove any preceding zeros. So what looks like a very long address now looks quite simple. There you go. That's IPv6 addressing. Now, other particular types of addressing? Well, yes, there are, of course. So you can see if it begins with 2001 here, this shows me that it's a global unicast address. What does that mean? Well, essentially, the global prefix means that this is a routable IP address, which means that if I have your host address, your machine address, we could basically communicate. Now, what many companies might want to do is they might want to subnet this network. So kind of chop it up a bit, make it easier to use, a bit more customizable, and it's also good for security. So, and again, on the right hand side, you can see the individual interface ID. And this is the network card that's in your Apple Watch, your mobile device, your laptop, your PC, in fact, your smart TV. They've all got network devices inside. So looking at the different types of networks then, I've mentioned that the global unicast address is publicly routable. You can communicate with anyone. But if you wanted to use it only on a local network, you could use the FC range of IP addresses. So FC00, for example. And these are routable addresses, and you can use them internally. FE80 is typically non-routable, so it's a bit like a private IP address. It doesn't go beyond your network card. FF is a multicast, so for example, if you were just casting to a specific group of users, let's say. And again, the Anycast, which is similar to the global unicast, again, these shared addresses. Anycast, Andy? Who uses that? Netflix. So if you use Netflix, you're Anycasting. There you have it. In 10 minutes, you're an expert on IPv6. Now you're a champ. So there you have it. IPv6 in 10 minutes. I think I did it. Hey, listen, if you enjoyed it, give me a big thumbs up, bump the subscribe button, ring that bell, and if you get any comments, get them down below. That's it for today. I'll see you next time. Hey, thanks so much for dropping by today. Here's a couple of videos that you may enjoy, and while you're here, go ahead, click on the subscribe button and you won't miss out.